So X and Y are two lamps. X is rated at 12 volt 36 watt and Y is 4.52 watt. Calculate the current in each lamp. So we're going to be using a formula, P equals IV, and then we need to rearrange to get the current. I equals P divided by V. And if we put X there and Y there, so for X, it'll be 36 divided by 12. And then for Y, 2 divided by 4.5 gives us 0.44 recurring. And then that's going to be 3. So we got 3 amps and we got 0.444 amps recurring. So that is the correct current that would be flowing through each of these lamps based on the voltage supplied. So the lamps are then connected in the circuit shown in the figure below. The battery has an EMF. EMF, by the way, just means, it's another word for voltage. Has an EMF of 24 volts and negligible internal resistance. R1 and R2 are chosen so the lamps are operating at the correct working voltage. So let's take a look at the diagram. So you can see X and Y are in the parallel part of the circuit, and then you've got R1, which is in the main series bit, if you like. A couple of things to recap before we answer these questions. So the potential difference across R1. So just a reminder, for parallel circuits, the current splits. Okay, I did cover this in my previous videos. The current splits and takes the path of least resistance, but the voltage is the same along each branch. Now, why am I saying this? Well, we're going to need this understanding for later parts of the question as well as this part here. Whereas for a series circuit, the current is the same all the way around the circuit, but the voltage is shared, if you like, amongst the different devices in the circuit. So you may have a bulb, you may have a resistor, you may have a fan, whatever it may be, the total voltage available from the battery is distributed amongst those devices. So with that said, if you look at the parallel part, we know that there is 12 volts running through X because it tells me that. So there's 12 volts running that way, which means there must be 12 volts running along this branch because in a parallel circuit, as I said, each branch gets the same voltage. So if we have 12 volts allocated to the parallel bit, that means in the series bit, there must be 12 volts left over for R1 because 12 plus 12 makes 24. So the answer for part 1 is 12. Number 2, calculate the current in R1. Well, that is going to bring into this point here that the current splits in a parallel circuit. When it splits, it recombines and then will flow around the series part of the circuit. So if I use a different color to highlight this bit, if you look at branch X, the branch where X is located, we know that there is 3 amps flowing. So I'll just write that there. Whereas the branch where Y is located, there is 0.44 amps running through that part. And at that point there, which I'm just marking in with the arrows, they 2 parts of the current will recombine, and then that total current will flow around the series circuit. So if we got 0.44 along one branch and 3 amps along the other branch, therefore it's just both of them added together. So 3 plus 0.44 gives me about 3.44 amps in the main circuit. Number 3, calculate the resistance of R1. We're going to be using the formula V equals IR, and then R equals V over I. The voltage along R1, we worked out earlier on, is 12. The current along R1 is the total current in the series circuit, the main circuit, which is this number. So 12 divided by 3.44. So I'm just going to put the full number off the calculator, gives us 3.48837. And then rounded to, say, 2 decimal place, that would just be 3.49 or 3.5 to 1 decimal place. So it's really important with physics calculations and maths especially, and the ones you see in chemistry as well, is you put full number off the calculator and then only round right at the end. Because if you accidentally make a typo and you put the wrong answer on the line, the examiner can see your previous work in and the previous number off the calculator and still award you the full marks. So it's really important you don't round up too early. You just put the full numbers down and round right at the end. Right, now that we have the resistance calculator for R1, we're going to look at R2 instead. And now we need to calculate the potential difference across R2. So if you look where R2 is, if I just show this in green, we have this piece of wire there, okay? And that's one of the branches of the parallel circuit. So we know that 12 volts is running down that entire branch. However, of that 12 volts, we have been told from the first bit, just circled there, that 4.5 has been allocated to the bulb Y, which means the remaining 7.5 volts, because 7.5 plus 4.5 is 12, must be allocated to R2. Remember, when you have a strip of wire and there's multiple devices along that wire, the voltage is shared amongst those devices. That's the sort of series part of the understanding, if you like. Anything on the same strip, the voltage is shared. So therefore, the voltage across R2 is 7.5 volts. Finally, calculate the resistance of R2. So V equals IR, and then R equals V divided by I. We know that the voltage along R2 is 7.5. So it'll be 7.5 divide 0.44 gives us an answer of, again, number straight off the calculator, 2 decimal place again, keep in line with the accuracy of the other numbers I've used. That'll be 17.05. So 17.05 ohms is the resistance of R2. Just before we finish, I just want to make a point about the number of marks for each of these parts, right? So you will see they're only 1 mark. And the formulas we're using, which I've just circled there, are very easy. What's difficult about this question is the thinking behind each part. You've really got to think about what is going on. And that comes from having a good, solid understanding of properties of a series circuit and a parallel circuit. Because if you don't know the facts of those two circuits, it's going to be really difficult to get the right answer. So you have to think through each part really carefully, as I just did there, thinking aloud. And then once you know what to do, the actual number crunching, if you like, the maths is really simple. As you can see, it's just basic numbers and basic formulas, but it's the understanding that makes this difficult. If you've had any value from this video, please like and subscribe. It helps the channel grow, and it really, gives me more time then to make these videos. Please check out the other content I've produced. And thanks for watching. I will see you in the next one.